Hey everyone, another video where we're looking at a different function today, and today we're looking at the square root function. All right, so namely the square root function makes sense what it is, and so let's just have a look at the shape of the square root function. Okay, so um, when x equals 0, y equals 0, the square root of 0 is 0, so it starts at the origin. Okay, and as x increases, like let's say x equals 4, then y equals the square root of 4, so y equals 2. And so as x increases, y increases as well, but not as quickly. And in fact, what this looks like, it's actually the inverse function of the parabola. So it looks like a parabola, but lying on its side, and so it sort of comes up and it goes out like that. Now, it's only the positive side. If you think about the quadratics, the quadratic y equals x squared looks like that. So if you think about this, should be lying down on its side like that, and it is. But because the square root of x must be positive, you only get that sort of positive side. You do not get the lower end of it like that area in there, that area in there. It's not part of the graph, and so y equals x is only what we've got in front of us there. Exactly like that. So it's a nice and simple sort of function. And so let's have a think about it. What's the domain of this guy? Well, it's from 0, including 0 to infinity. Okay, round bracket on infinity because it doesn't include infinity. It's not a number. And the range is also from 0 inclusive to infinity. Okay, domain and range, nice and simple. If it has transformations on it, like the following, then various things can happen. I'm going to draw sort of like 4 different graphs here, okay? Again, I've run out of space, but we'll see. Here we go. Okay. So firstly, you're going to have the turning point. Well, I'm saying turning point, but the 0, 0 point, right? So that 0, 0, I'm going to call my language is going to slip to turning points, okay? So I might call it starting point or something like that. So the starting point was 0, 0 there. So what happens if we have transformations? Then the starting point will move to HK, okay? So normally, so we'll have here HK, it'll get moved to there. So your turning points, whatever you want to call it, starting point will look like that for HK, all right? Now, that one will look like that if A is greater than 0 and B is greater than 0. So now we've got to sort of like take into account, we've got sort of 2 things going on here, okay? So HK, it'll look like the normal function if it's like that. Let's have a think about if we've got other things. So let's do, so we'll do A less than 0, B greater than 0. Then we'll do A less than 0 and B less than 0. Which combination haven't I got left? I still need to do A greater than 0 and B less than 0. So let's just have a think about what these guys look like, okay? So over here, if A is less than 0, so about the front, then it gets flipped in the y direction, okay? So it still has its starting point at HK, but instead of coming up this way, it gets flipped in the y direction, and so it actually comes downwards, okay? I should have done a dotted line, but it comes down like that. So it gets flipped up the other side, so HK looks like that. Okay, so that's if A is less than 0, it's getting reflected in the x-axis from there. So that's what that will look like, okay? Now, let's have a look at this next one down here. If A and B, let's do that one last. We'll do if A is greater than 0, but B is less than 0. So what happens is that now this is getting reflected in the x direction, okay? So instead of it starting at HK, I'll just put HK there again. So that's our starting point. So instead of going up and over like that, it's actually getting reflected in the x direction. And so what it will look like is it will go that way. I'm sort of bumping into my own sort of other things there, but it's sort of going to get moved in that direction. Okay. And finally, if A is less than 0 and B is less than 0, again, if we start at HK, instead of going up this way, it gets reflected in the x direction, and then it gets reflected in the y direction. Okay, so what it's going to end up with, it's going to end up going down and to the left. And so it's going to come down that way. Okay. All you really need to remember is that the original function. So if you just remember this one, and just think about what the transformation is. So if B is negative, then it's flipping it in the X direction. If A is negative, it's flipping it in the Y direction. That's really all you need to remember, okay? So just going back to, so if we're just thinking about sort of this function, what's the domain and range for that one? The domain will be, it's starting from H and going to infinity, and the range is starting from K going to infinity as well. Okay, hopefully that makes sense. That's what the sort of the functions look like. And so let's have a look at an example here. So sketching y equals negative 2x plus 1 minus 3. Let's have a think. So our starting point is going to be at negative 1, negative 3. Okay, so negative 1, negative 3. So somewhere down here. That's negative 1, negative 3. Okay, in fact, that's going to be in the way. Get that out of the way. Okay. So that takes care of what that does and what that does. It puts it down to there. The only other thing we need to think about is, well, it's negative out the front. So that's going to, so instead of sort of coming up like that, it's going to flip it downwards down that in that direction. So it's going to go downwards. We just need to sort of get a bit of an idea what. Now that I know that it goes downwards, I'll label this here. What was it again? Negative 1, negative 3. And it might be also good to find out about what that y-intercept is, because that'll help us find out. So that's when x is equal to 0. And so y is equal to negative 2 the square root of 0 plus 1 minus 3. Negative 2 square root of 1 minus 3. So negative 5. So that helps us to sort of get a bit of an idea. So that if that's 3 there, then it's going to go through that point as well. So what does the graph look like? Comes out here, goes on like that. And that's the graph. That's y, that's x, and that's y equals negative 2 root x plus 1 minus 3. Okay, so hopefully that makes sense. Like I said, as long as you know what the original function looks like, and then you can think about how the transformations work to it. So if I was just thinking of our original, the original function here, so I think, well, the original function root x looks like this. The plus 1 moves it 1 to the left, so it becomes that. The minus 3 moves it down 3, so it becomes that. The negative 2, well, the negative out the front makes it go to that. And then the 2 does a dilation in from the x-axis, and so it makes it a bit wider, and so it ends up being a bit lower down like that. I hope that makes sense about sort of following what the transformations are doing in this particular case. All right, let's just have a look at a determining question, as we always do. What is the equation of this guy? All right, so just assuming it's a square root function. I didn't actually say that, but yeah, let's assume it's a square root function, otherwise it's a bit hard to tell. All right, and so what do we know? We see our sort of starting point / turning point is there, and we've also got some other point on the line. So what have we got? We've got y, and it's hx. Hx is equal to, we've got a, inside we're going to have x plus 3, and we're going to have plus 1 over there. So because it's plus 3 moves it negative 3 that way, and the plus 1 moves it plus 1 up that way. So that is all correct. So we've got those. And so that's the equation of our line at the moment. We just need to know what the dilation factor is. So let's sub in a point. Sub in 1, 6 in here. And then we get 6 equal to a square root 1 plus 3 plus 1. Therefore, 6 is equal to 1 plus 3 is 4. Square root of that is 2a plus 1, which gives a equal to 5 over 2. It's got the kids coming home. That's what noise in the background is. That's a 5 there. 5 over 2. And therefore, my equation hx is equal to 5 over 2 root x plus 3 plus 1. Hope that makes sense. See you in the next video.